So 4.1 is all about antiderivatives. So the basic symbol you're going to see when you want to do an antiderivative is the integral symbol. And sometimes you're started with something along the lines of f prime of x equals something like 2x, and it wants you to then find f of x, which hopefully is kind of obvious that if this is a derivative, you want to undo the derivative to find the actual function. So if we've got something like 2x, it's a polynomial. You have a number, x, the variable, and an exponent. This one's to the first power. So the good thing about antiderivatives is they just reverse the rules of derivatives, at least for the most part. So in this case, if you think about if you had like x cubed, and you want to take a derivative, you would drop down the 3, and you get 3x, and then you would subtract 1 squared. So we have to do that exactly backwards. We're going to add 1 to it, so 2x, add 1, and then you're going to divide by the 2. So that's really kind of how to take the antiderivative. You add 1 to the exponent, and then you divide by it. Now, you can always check this by taking the derivative. And then, how do you take the antiderivative of a constant? Well, the derivative of 7x is 7. So the antiderivative of 7 is 7x. So the antiderivative of a constant is just the constant times the number. Now the one thing that's a little bit tricky about this is, well, if you check the derivative, you'll get this. But what about like a plus 3? The derivative of 3 is 0. You'll get the same thing. Well, how do I know it's 3? I don't. It could be 5, 7, 9. So what we do at the end of any antiderivative, any antiderivative doesn't have any bounds. We haven't seen any numbers up here. So when you're just doing an antiderivative, you always put a plus c, which is a constant. When we want to find a particular solution, sometimes we get like an ordered pair to start with, and that'll let us find the actual constant. But for this lesson, most of them are just going to be plus c. All right, let's try another one here. So we follow our rules. We take 3x, add 1 to the fourth, and then you divide it by 4. If you were to take the derivative, the 4's would cancel. Minus 5x to the third, divide that by 3, plus 20x to the second, divided by 2, minus 4x, and don't forget the plus c. It's plus c, people forget it all the time, and depending on who your teacher is, if it's me, mine's a half a point, but you don't want to lose that point. It's a very easy point to get. And technically this 20 divided by 2 should just be 10. I wouldn't change any of these in decimals. I mean, you could. I wouldn't especially change the second one to decimal, but that's the main thing. Now, the problem is not all of these are going to be polynomials. Some of them are going to be rationals, like this one here. Well, the trick for this particular one is write x to the negative 3. Okay, now it looks more like a polynomial. So it's going to be x to the, add 1 to it, negative 2, divided by negative 2, plus 2x to the second divided by 2, plus 4x, plus c. And if you want to clear all this up, you can have negative 1 over 2x squared plus x squared plus the 4x plus c. Coming down now. All right. So when you have a polynomial, you can just use your power rule. When you have a rational, you can swing your exponent back up to the top and work with it that way. Let's see a couple different other situations here. And actually, that's one of the trickiest things is you're going to see a lot of different types of problems. And when you do the homework, make sure that you take a look at all of them. I mean, if we skip one and one of the evens looks like it's an interesting problem, you really should do all of them and you should practice them. Doing more, something like 7 again really is not that useful, but you have to see all the different types of problems and try them all out. So let's see a couple more here. Okay, so what I would say if you see a cosine or a sine, think about derivative of sine. Derivative of sine is cosine. Derivative of cosine is negative sine. So it's probably, the antiderivative of cosine is probably going to be sine. Now the derivative of cosine is negative sine of x and plus c. The question is, should it be negative or not? Now you can memorize this, but at least for sine and cosine, I would just say, take the derivatives. The derivative of this is that. One quick note that I didn't really talk about. This little dx. Notice it's on every one of these problems so far. that is, for the most part, it's actually, if you think about, if you go back to chapter 3, when we're talking about differentials, should look familiar, cosine of x dx. If we took the differential of sine of x, we would get cosine of x dx. But as far as we're concerned, this is really just talking about what variable we're talking about. This is our integral symbol. I mentioned at the beginning, but it's an integral. Or the integral symbol telling you to do the integral of this function in terms of x. That's kind of what the symbols mean in this case. Yeah, all right, moving on here. So I think it's kind of obvious that the antiderivative sign is going to be cosine. But think about if you're doing the derivative sine of 2x, that would be 2 cosine of 2x, right? 2x doesn't change. So you have cosine of 2x. Now, if I do the derivative, I'd be multiplying by 2. The antiderivative, you could do what's called a u substitution, which you'll learn later on. But for something simple like this, you're just reversing it. You're not going to multiply by 2. That would be the derivative. You're going to divide by 2. Now, the problem is, this derivative isn't going to match up. 2 will cancel out. Take the derivative of the inside, you'll get a 2, cancel this 2. Problem is, derivative of cosine is negative sign. So in this case, we have to flip our sign and put a plus c. Alright, so we got one more different type of problem. Not by any means going over all the different types of antiderivatives. And as a matter of fact, we have an entire chapter talking about antiderivative techniques, integration techniques. So this is just the tip of the iceberg. These are some of the easier ones. But you're going to see a lot of different ones that even still fit in this section. Alright, let's look at this next one. Well, we did a rational before, kind of right above us here, number 8. And the way to do this particular one is to split it up as 2 separate pieces. And don't put them under a common denominator, put them both under their own denominator. So this is the integral of x to the 1, or 2 halves, divided by x to the half, that's the square root, plus 1 over x to the half, the square root. And then we can kind of simplify this all up. And technically, the dx kind of goes with the whole thing. So 1 minus a half, subtract for division, you end up with x to the positive half, plus x to the negative half. And now, all of a sudden, I have things in my normal form. So it'll be x to the 3 halves, add 1, and then divide by 3 halves, or in other words, multiply by the reciprocal, 2/3, plus x to the positive half, because you're adding 1, divide by half, or multiply by the reciprocal, plus c. Now, one of the things that you're going to see that's going to be kind of tricky to tell is this might be your right answer, but it also may not be the answer you see in the back of the book or the answer you see on a multiple choice question. The answer on a multiple choice question might do something like this, taking out 2x to the half, or 2, maybe even 2, go back to that square root of x idea. If I do that, you end up, if you take out the square root, dividing it out, you're taking out a half. That's going to be x over 3 plus 2, and plus c. And notice that that plus c is just still on the outside of the whole fun thing. So in this case, oh, sorry, this is not 2, this is just 1. Took out the 2. So this is what you might see in a multiple choice question. This is what you might see in the back of the book, taking out a GCF and kind of cleaning things up a bit. Now, as far as I'm concerned, this is just fine. You've done the antiderivative, you put plus c. So on the test, I'm cool with this. But unlike the AP exam, you might have to be able to tell that these two are the same. And it's not always easy to tell right off the bat. You gotta do a little bit of work. Maybe you have to FOIL this out and see which one it is. If that's answer D, you might have been working with A, B, and C for a little while. So there's a little bit of algebra sometimes at the end of these problems.